All right, here we go with Exponents and Logarithms Day 6, and we're going to look at our log laws a little bit more today. And you'll notice a box at the top here full of helpful rules. So these are things that we will see again and again, and rather than us doing maybe all the math to get to a solution, we can remember one of these rules and we can take some shortcuts. Okay, so we did a little bit of this last day. Write the following in terms of log 3 and log 4. So we want to remember our multiplication law here. And what I can recognize is that 12 could be rewritten as the product of 3 and 4. So I'm going to rewrite this argument as the log of 3 times 4. And multiplication law tells us that we can rewrite that now as the sum of two logarithms. So we're going to get the log of 3 plus the log of 4. Okay, so we've rewritten the expression in terms of log 3 and log 4. Okay, same thing with this next one, the log of 36. I'm going to do a bit of a shortcut here. 36 is 9 times 4, but 9 is also 3 squared. So I'm going to rewrite this as 3 squared, that's our 9, times 4. And so using multiplication law, we can rewrite this as the log of 3 squared plus the log of 4. And then power law tells us that we can move that exponent out in front as a coefficient. So the log 3 squared becomes 2 times the log of 3 plus the log of 4. All right. Moving along. So find the exact value here. Let's just remember that the square root of 7, just a little note here, the square root of 7, we can rewrite that as 7 to the power of 1/2. Okay, so we want to keep that in mind here. So our first step is we're going to rewrite the expression log base 7 of, and I'll just change the argument to 7 to the power of 1/2, and that's being raised to the power of 1/4. Okay, so this is our power law of exponents. We've got a power raised to a power, which tells us to multiply the exponents. So our next step here, we've got log base 7 of 7 to the power of 1/2 times 1/4 is 1/8. Okay, so now we're thinking about this as 7 raised to the power of what is equal to 7 to the power of 1/8. Okay, well, another way to think about this is, let's use power law here. Let's take the exponent of 1/8 and let's move it out in front as a coefficient. So we're going to get 1/8 times log base 7 of 7. Okay, now this is 1/8 times log base 7 of 7. And this is one of our little tricks here. Log base 7 of 7, that is 7 to the power of what is 7? Well, 7 to the power of 1 is 7. So this whole expression goes to 1. Okay, so 1/8 times 1 is 1/8, and that's our solution. Okay. So kind of the same idea with the next one. We've got log base 5 of 5 to the power of 6 minus log base 5 of 5 to the power of 2. Let's use our power law to begin. We'll move those exponents out in front as coefficients. So I'm going to rewrite the first term as 6 times log base 5 of 5 minus 2 times log base 5 of 5. And the log base 5 of 5's, 5 raised to what power is 5? Well, 1 and 1. So ultimately we've got 6 times 1 is 6, minus 2 times 1 is 2, and our solution here is 4. All right, moving along. Change of base. Okay, so we have talked about if we're looking at a logarithm and we do not see a base, let's just say we've got the log of 7. Okay, there's no base there. We assume that the base is 10. Now, most of our calculators are set up to work in base 10, and we can't actually change the base in the calculator. There are some special calculators around where you can change the base, but for the most part, they are set to base 10 logarithms. This is where change of base comes into play. So if we've got log base b of a, this is right here, log base b of a, we could rewrite that as, and I'm going to, before we take that any further, we could rewrite that as just the log of the argument, so the log of a, divided by the log of the base, which is the log of b. Okay, and then going one step further, we could rewrite this expression with any base, so long as the base is the same for both top and bottom of our fraction, we can rewrite that expression with any base and it's still going to be equal. So this is one of our helpful rules from above. So we could rewrite this as log base 2 of a divided by log base 2 of b. We could rewrite this as log base 7 of a divided by log base 7 of b, and all of those expressions are equal to one another. Okay, so evaluate to 5 decimal places. This is log base 4 of 37. And so what I was just saying is it would be difficult, or most calculators won't allow you to do this. They won't allow you to change the base to 4 here. So this is where our change of base rule comes into play, and we can rewrite this as the log of 37 divided by the log of 4. Now it says to evaluate to 5 decimal places. We're just plugging that directly into our calculators. Log 37 divided by log 4, and what we should end up with is something like this, 2.60473. 2.60473. Okay, so same idea with the next one. Because we can't plug log base 2 of 80 into our calculators, we're going to use the change of base rule to rewrite this as the log of 80 divided by the log of 2, and we can punch that into our calculators and we should get something like this, 6.32193. Okay, next one. Evaluate this, log base 25 of 125. Now, one of the things we want to be able to start picking up on, okay, 25 and 125, can we rewrite those numbers as powers with the same base? And the answer is yes. Okay, so step 1 here, I'm just going to use change of base rule to write this as the log of 125 divided by the log of 25. Okay, now we could punch that into our calculator and we could solve. Okay, but this one we can also do without a calculator because I know that 125 is equal to 5 cubed, and I know that 25 is equal to 5 squared. So with our next step, let's rewrite each of those arguments. So I'm going to rewrite the log of 125 as the log of 5 cubed. And I'm going to rewrite the log of 25 as the log of 5 squared. Okay, now from here we can use power law, Let's move those exponents out in front as coefficients. So we've got 3 times the log of 5 and 2 times the log of 5. Now we've got common factors here of log 5. Those cancel each other out, and we're left with 3 over 2. That's our solution. Okay, how about something like this? We've got 6 times log base 9 of x minus 12 times log base 27 of x. Okay, so let's begin by using power law. We'll take those coefficients 6 and 12 and we will move them to become exponents to the argument. Okay, so 6 times log base 9 of x, I'm going to rewrite this as log base 9 of x to the power of 6 minus, and then this will become log base 27 of x to the power of 12. Now, from here, let's use our change of base. So I can rewrite log base 9 of x to the power of 6 as, as the log of x to the power of 6 divided by the log of 9. And I can rewrite log base 27 of x to the power of 12. I can rewrite that as the log of x to the power of 12 divided by the log of 27. Okay, now we're looking at subtracting fractions here. We know from way back that we need a common denominator in order to do that. I'm looking at the log of 9, I'm looking at the log of 27. I don't have a common denominator, but what I notice about 9 and 27 is each of those numbers can be rewritten as a power with a base of 3. Okay, so that's going to be my next step here. We're not going to touch the numerator to begin. So we've got the log of x to the power of 6. The log of 9 I'm going to rewrite as the log of 3 squared. Okay, then we're subtracting the log of x to the power of 12. And the log of 27 I'm going to rewrite as the log of 3 cubed. Now, from here, let's use power law. Let's move all 4 of those exponents out in front of the logarithm as coefficients. So the log of x to the power of 6 becomes 6 times the log of x. The log of 3 squared becomes 2 times the log of 3. Okay, then we've got 12 times the log of x and 3 times the log of 3. Now, we can simplify those coefficients. 6 and 2, we end up with a 3 and a 1. 12 and 3, we end up with a 4 and a 1. So in our next step here, this is what we're working with. We've got 3 times the log of x divided by the log of 3. And we're going to subtract 4 times the log of x divided by the log of 3. Okay, and so what we notice now is we do have a common denominator, so we can combine those numerators, and in fact our numerators are like logarithms. So 3 log x minus 4 log x, we are just adding and subtracting the coefficients. That gives us negative log x, or negative 1 log x, divided by the log of 3. And all sorts of different ways that we can write this, what are we being asked to do here? Just to simplify. It would be okay to leave it right like that. Negative log x divided by the log of 3. But let's go a step further here. We're going to use change of base in reverse. So I can rewrite this as the negative of log base 3 of x. I could also rewrite this as log base 3 of x to the power of, the coefficient was -1, so the exponent becomes -1. And I could also rewrite this as log base 3 of, well, what's x to the power of -1? 1 over x. Oops. Okay. So more change of base rule, and I touched on this at the top of the page here. But let's work with this first expression here. We've got log base 4 of 37 divided by log base 4 of 12. So I'm going to take the numerator and denominator there, and I'm going to use change of base with each of those. So log base 4 of 37, I'm going to write as the log of 37 divided by the log of 4. And log base 4 of 12, I'm going to use change of base to rewrite that as the log of 12 divided by the log of 4. Okay, now we are dividing fractions, so we could multiply by the reciprocal. I'm going to rewrite this as the log of 37 divided by the log of 4. And I'm going to multiply this by the log of 4 divided by the log of 12. And we will know that the log 4's cancel each other out. And this becomes the log of 37 divided by the log of 12. Okay, so I'm just going to rewrite that up here. This is log 37 divided by log 12, and those two expressions are equal to one another. The bases of the two logarithms on the right, you don't see them, so we can assume that they are 10. So log base 4 of 37 divided by log base 4 of 12 is equal to the log of 37 divided by the log of 12. Okay, so we can cut to the chase here. Log base 15 of 37 divided by log base 15 of 12. Same idea. This is going to be equal to the log of 37 divided by the log of 12. Okay, and moving on. So why does a to the power of log base a of b equal b? Okay, well let's choose some values for a and b. Let's say that a is 3. Okay, so we'll say that a is 3 and b is 6. Okay, those are just arbitrary numbers. So I'm going to rewrite this as 3 to the power of log base 3 of 6. Okay, now at this point, we don't know what the solution is. Well, we're told that the solution is going to be 6, but the question is why. Okay, so this is an exponential at the moment. Let's convert it to a logarithm. Whoops. So let's convert to a log. Okay, so the base of the exponential becomes the base of the logarithm. So we're going to get log base 3 of our solution, that's our question mark, is equal to the exponent, which is log base 3 of 6. So we see that our question mark here is equal to 6. Okay, so this is one of our helpful rules above. If we've got an exponential where the base of the power, a, is equal to the base of the logarithm in the exponent, our solution is going to be whatever the argument is. Okay, so without having to do any work, we would say, okay, a to the power of log base a of b is going to be equal to the argument, which is b. So we'll use that in some of these next examples here. So we've got a to the power of log base a of 3 plus log base a of 5. Now we've got the sum of two logarithms in our exponent. We will use multiplication law to begin. So we're going to get a to the power of log base a of, now the product of 3 and 5. So we've got 3 times 5. And so our solution here is going to be whatever the argument is, which is 15. Okay, same idea with the next one. So I'm going to rewrite this as a to the power of log base a. That coefficient 2 is going to become the argument's exponent. So 6 squared is 36. There's power law. And we're going to use division law here. We're going to divide this by 12. And so our solution to this is 3. Okay, and one last one. So we've got 1 divided by log base 2 of 10 plus 1 divided by log base 5 of 10. So we've got the reciprocal of these logarithms. Without skipping any steps, this is what it looks like. I'm going to rewrite log base 2 of 10 using our change base rule. So that's the log of 10 divided by the log of 2. Okay, and same thing over here. Log 10 divided by log 5. Okay, so we can reciprocate these or flip them. The first expression becomes the log of 2 divided by the log of 10. And then we've got the log of 5 divided by the log of 10. Okay, we've got a common denominator, so we can combine the numerators. That's going to be the log of 2 plus the log of 5, all divided by the log of 10. Okay, multiplication law on the top, so we've got the sum of two logarithms with the same base, so we can multiply the two arguments. So we're going to get the log of 2 times 5, all divided by the log of 10. 2 times 5 is 10, so we've got the log of 10 divided by the log of 10, which is equal to 1. Okay, and that is it for today. You'll notice that the homework today, section 5.3 from your workbook, numbers 1 to 5, that's the same as last day. If you didn't do all the questions, like you just did every second letter, A, C, E, and so on, I would just do the remaining letters. Okay, but the whole idea of the two lessons is just working with our laws of logarithms. Okay.